I don't know about you. All right. Good morning, everyone. Today is Tuesday, November the 23rd. This is the day before our Thanksgiving break. So after today, I won't see you all online until the following Monday. How exciting. All right. Make sure that all of you are caught up on your stuff and make sure that you check the grade book to make sure all the scores are in there. I sent an email out last week telling all of you, hey, check your grades, make sure that everything's in there. Nobody got back to me, and then yesterday I happened to just look, and I just looked for some trends, and I found two people that grade book was a 0, but when I checked to see if you did it, you actually did it, but it just didn't transfer over. I should be the one that has to notice that or check. I need you to help me out and verify that all your grades are showing in the grade book for this class, because for whatever reason, some of the quizzes that you put in there aren't showing up in the grade book. I don't know why. It must be a new feature. So make sure you do that. All right. Upper and lower bound. What is the lower bound of this polynomial function? So what do we have to do? Yeah, we need to do synthetic division on negative x, right? Yeah. Graphing may or may not work. I'll leave it up to you to kind of test that theory. I would definitely, if you're going to graph this using that method, check all the examples they have in this module and confirm the graphing method, which I haven't even gone through. I haven't even verified myself if it even works, to the answers they get mathematically, because I hate for you to make assumptions without actually testing your theory. And you might be right. I don't know. Top of my head, it sounds like it would work. So we have to plug in negative x. Remember, we're doing the lower bound. So make sure on your test, you take note. Do they want lower bound or they want upper bound? Because if we're doing lower bound, we have to do this. So we plug in negative x and then we simplify. Just at the top here, a negative to an even power. Oh, I didn't get my pen yet. I can use my finger. That's going to be a positive number. Negative to odd power, that's going to stay negative. And then that's going to be positive because it's an even power. That's going to be negative, of course, and then, of course, negative. And then we have to do just one little thing. Negative times a negative makes this a positive. That stays positive. Negative times a positive becomes negative, and then our negative. So hopefully we all did that correctly. And then you have to do synthetic division, just like Rachel says. And we need to test starting at 1. So we start at 1, and then we go to 2, and then 3, and so on. So I didn't show the work for 1. I didn't have enough room on my screen, but I started at 2 on the work on the screen just to do synthetic division with what we have here. And our goal here is to get all of these numbers to be either all non-negative or all non-positive. So right now, that's a non-negative, 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 and then that's a non-positive. So this negative 39 kind of ruins it. So 2 doesn't work. So we go to the next number, 3. And when we do that, look at that. All the numbers down here, these are all non-negative. All non-negative. Remember, 0 is okay because it's neither positive nor negative. So it qualifies as being a non-negative number. When you get all of these, just like that, we know that 3, remember lower bound. So even though we use positive 2 and we use a positive 3 here, what is the answer? What is the lower bound? Yep. So negative 3 is the lower bound. Exactly. So feel free to graph the original function and see if your theory of using like some graphing method, which we haven't gone over, determine upper and lower bound, um, gets you the same answer. And again, I would do quite a few examples and kind of confirm that with what the answer is. All right, so that's lower bound. Any questions? Okay, let's go to the next one. So we got the polynomial function has one positive zero. Between what two integers does this positive zero occur? I kind of think this is a freebie. So those of you who were able to finish these 5 questions for today, how did you do it? So Rachel says we can graph to get a better look. You can use a PQ list, graphed it. Yeah, I think a PQ list or graphing. I think both of those are good. Graphing is easier. Yeah, no, you are right. Usually, no, graphing is usually the easiest way, and we seem to use the graphing method for a lot of different types of problems because it shows so much. So I'm telling you, this has one positive solution. So if you use like Descartes' rule of sign, and we did the sign changes, it would be. Let me just for fun, just do it on the screen real quick. Descartes' rule of sign. So we got positive to a negative. That's one. Um, and oops, and same and then same. So yeah, so based on Descartes' rule of sign, we're gonna have one positive solution, which is what the problem actually already tells us. So we just kind of confirmed what is already told to us. But we could graph this, and we can see like on the axis. Let's say it does. Oops. Yeah, let's say it does this, which actually no. Let me do my end behavior right. Um, so let's pretend it does that, right? So there's my one positive zero. So we could graph it and just see, hey, which number is to the left, which one's to the right of it. We really could have done it that easily. Or we could just do it the like a long way and kind of just test things mathematically. We could use synthetic division, which I do here, or we could just plug in values. We can just plug in like we can do f of 1, f of 2, f of 3, f of 4, f of 5, all the way up until we figure out the answer. Um, so the answer, well, you can probably guess based on my work is what? So it's between 6 and 7. Yeah, between 6 and 7. When I did synthetic division, what we're looking at here is the remainder. So remember when you do synthetic division, the remainder theorem, the remainder is the same thing. So if you were to plug in 6 into your function and solve, you would get -8 as the answer. So that's the remainder theorem, I believe. If you were to plug in 7 into x and to evaluate that, f of 7 equals 48. So that's the remainder theorem if you've forgotten. And this right here, this tells us when x is 6, your y value is -8. When x is 7, your y value is 48. So this is below the x-axis. This is above the x-axis. So somewhere between 6 and 7, it intersects the x-axis. And that is basically what I wrote here in lots of words. So same thing. This is below the x-axis. This is above the x-axis. Therefore, your one positive zero is between x equals 6 and x equals 7. Um, did anybody do it this way? Yeah, the way I did it on the screen is definitely the longest way to do it. Yeah, graphing would have been the easiest, and to be honest, if I was taking this test and I was in your shoes again, I would graph it just to pick out the answer. But this is how the problem was intended to do. It's how the module showed it. So I think it's important to at least understand both ways, whether or not you want to use this method. So you got to think about like these methods. They seem, it's like why would we do this? Well, not too long ago, we didn't have access to graphing calculators or like Desmos online. That didn't exist. So and these Descartes rule, doing upper and lower bound, this was well before we had easy access to those that technology. So let's say in let me think. So I was in high school in between 1997 and 2001. So and I had a calculator. I had a graphing calculator back then. I had a TI 86 for my classes. So let's say 1995 and before, there's a good chance you did not have a graphing calculator. Well, you would definitely need to know how to do this. That must have been rough. Yeah, we had no Twitter, no Instagram, no Facebook, none of that stuff. No cell phones to text each other. We had to actually like talk to each other in person or call each other over the landline, the phone. Yeah, it was rough. Let me tell you, times were good. Oh, and the music was better too, and I think everyone says that. Um, yeah, the music was definitely better in the '90s and early 2000s. Just saying. All right, let's keep going. In behavior. So these should be pretty easy. This you're just confirming true or false. So the limit. So when x goes to which direction? Are we going left or right? What does this tell us? Yeah, so left. So this one tells us when given this function, and when x goes to the left, like infinity, what happens to the end behavior here? So we only care about the first term. This first term determines the end behavior. Well, it's even, so they both go up or they both go down. So what does this negative tell us? Yeah, it goes down. And the statement says it goes up. So is that true or false? Yeah, that's definitely false. All right, this next one here, the limit as x approaches infinity of this function. So it looks like, hey, they're both even again. So they both go up or down. Yeah, they both go up to U-shaped. So and it's telling us it goes to infinity. Is that true or false? Yeah, that's true again, or not true again. That's true. And then this last one here, we have the limits as x goes negative infinity to negative x to the seventh. So you tell me, does the end behavior look? So I'm going to say A. Does it look like this, or does the end behavior look like this? Let me get a little polling tool here. So for that third one, is the end behavior A or B? And when in doubt, we can either graph the entire thing or just make it easy on yourself and just graph the first term. That's what I would do is just graph the first term. That way you don't see like all these extra wavy stuff that's going on in between. It'll be easier to do that. So it looks like some of you aren't here. Three of you are tabbed out, or I don't know, maybe you're on your Instagram. Um, all right, three people still not here. Again, come into live sessions. You come to live sessions because you're actually going to be here. You want to change your answer? Okay, let me cancel that one and let me do it again. All right, re-enter your answer, A or B. Neuro should have a disclaimer. Yeah. Note: poll is final. Answer is final. Yeah. So it looks like a lot of you changed your answer to B. Yeah, the end behavior is definitely B. And it's because, well, it's odd, and it's negative. So because it's negative, it flips it upside down. So that's why it's B and not A. So this tells us as x goes to negative infinity. So as we go left, um, our graph goes to infinity. Is that true or false? And let me hold on a second. Don't put anything yet. All right, it's too late. You guys put true. All right, yeah, it is true. I was gonna do a poll. Yeah, it is true. That is true. All right. All right. Let's go to the next one. So now, yeah, this one's not too bad. This one's not too bad. As long as you understand the notation. All right. This is also a pretty easy one. I'm talking about multiplicity, and we 1.06 day 2. I'm talking about this polynomial, and depending on like the powers, it's either going to pass straight through. It's going to pass through in a cubic fashion, like a little wavy, right? Or it's going to bounce off. It's going to touch it and just bounce right off. Okay, so let's start here. So what zeros does it pass through? X equals what? See, all of you are doing coordinates. Yeah, x equals 0. And I believe for this one, we just want the x equals, x equals 0. We don't care about the y value. So yeah, it just talks about behave at its zeros, not the coordinates, zeros. So it passes through at x equals 0. What about the pass through it in a cubic fashion? What about that one? X equals 2. That's correct. And then the bouncing one, x equals 4. Yeah, pretty easy. Bounces because it's even. Passes through in a cubic because it's odd, and then just passes straight through in a straight line just because it's x to the first power. So if you need to review those rules, check out your notes, the recorded session, the modules for 1.06 day 2. All right. Let me put A, B, C, or D because I would have thought ahead, I would have done that. So A, B, C, or D. And really, you would only know the answer to this if you actually did all 5 questions yesterday and got to this one. It's not hard. Those of you who finish it, how did you determine what the answer was? What was your approach? I started by plugging in 0. Oh, actually, that would work too. Yeah, that's a good way. All right. Unfortunately, one of you are tabbed out. You found the sound of my voice to be very boring and soothing, and you fell asleep. Maybe that happens. That happens. All right. Let me show you the results. The answer is definitely C. Yeah. Wait, hang on a second. Neuro messed up. I don't know if you noticed the participation. It says 7 out of 8 answered. They didn't fix it. They did not fix it. So I think that first polling where I thought they did fix it, I think somebody had quit out when I started the polling, so it like removed one person, so it looked like they fixed it. If you know what I mean? Because everyone answered except me, of course. All right. Well, just kidding. They did not fix it. Sounds like them. So was it Rachel that says you plugged in 0 into X? I don't know. Yeah, okay, it was Rachel. Okay, so yeah, that works. Yeah, if you could, basically, if you notice the the y intercept is different for all the problems. So if you plugged in 0, you got 0 minus 0 minus 0 plus 12. So the y intercept is 0 comma 12. Well, that's a negative y intercept. That's a negative y intercept. That's a negative y. You know what? Based on just the y intercept, you could have found the answer to be C like super quick. Did everyone see that? Like super super quick. Did everyone see that? Nice, nice. I like it. Yeah, did everyone see that? Yeah. So maybe on your test, finding the y intercept might be a really quick way to see the answer. Hmm. And then you can always remember it's a big test and it's worth a lot of points. So also graphing it to see what it looks like visually is really the sure way to confirm um, what it is. So I would do both ways. Oh, hey, by the way, um, everyone go to the OHS. And then go to your. Let me open mine too, so I can guide you. I uploaded a new file last night, and you might find it useful. I might email everybody about it too before the test. Let's see. Let's see. How about you? My OHS is super slow this morning. And I clicked the wrong class. All right. So under course content, if you scroll down to unit number 5, and then under you have guided notes, and I added a new file, and this is MTH 403A overall grade calculator. So if you just download that Excel document, actually, let me just download it real quick, and I'm going to show what it looks like. Oh, wait a minute. When you click it, yeah, make sure you download it, not just because if you click it, it just like shows what it looks like. So make sure you click download. You actually get the file on your computer. And then open up an Excel and let me just go to, I'm going to share my screen. Tools. Share screen, share my window. We are sharing. Let me make sure I don't have anything else open, like my grade book. Okay, I don't. Yeah, that would be honestly tragic if I did that. That would be not good. Okay, everyone should see my window. I'll make it a little bigger. All right, so this is what you should get when you download my little Excel document, and this might work for all classes. So if you want to kind of change some numbers, I'll show you how you can apply it to other classes. So if you go to, I already changed the options. So oops, make this bigger too. Um, so at least for everybody in pre-calc, currently there is 355 points total. Your final is worth 125 points. So that's already filled in for you. There might be, depending on if you started the semester late, and you were exempted from like maybe the first couple assignments for whatever reason, but I'm pretty sure I made everyone do it regardless if you came in this class late. But it should be 355. You just go to your pre-calc gradebook and it'll show you how many points, right now you have 355. The final is worth 125. And then in the very end, when we're all done with this semester, you'll have a total of 480 points in the gradebook. So that's already filled in for you. And then on this page, what you're going to do, you have two options. You can fill in up here what your current points are in the class. So for example, if you have 284 points, you type 284, hit enter, and it shows that your current grade is an 80%. And then, just kind of self-explanatory, it tells you what you need to get on the final to earn a specific grade. So if you're somebody with an 80% going to the final, it is not possible to earn an A in this class. Well, kind of makes sense. You have a really low B, an 80. You can't expect your grade to jump 10%. But if you want to keep your B, you need to get at least a 98 out of 125 points. And that'll give you a 78.4 on the final. And then your overall grade is going to be a 79.58. And it will round up. So in the grade book, it rounds up to a B. And that's why it's like that. And then, of course, if you want to keep a C, you need to get a 50 out of 125. And if you want to, if you have a B in the class right now, 80%, and you miss every single question, you get only 1 point correct, 1 out of 125, which pretty sure you could guess and at least get one right. If you fit, you will fill this course if you get 1 point on that test. So, and you can just play with these numbers, and then down here you can manually check your score. So, for example, if you got a 284 out of whatever, you have 80% in the class, and then you can just kind of mess with, if I get 100 points, what do I get? If I get 75 out of 125, or if I get, I don't know, 1 out of 2. Yeah, see, a 2 out of 125 will get you to pass the course with a D. But yeah, so that's the spreadsheet. Feel free to kind of play with it and see where you need to be. It might also encourage you to retake your past tests. So I did open up all the exams for a second retake in pre-calc. So you can go back to Unit 1 and retake that test at your own time. You have until December 12th to do that. So if you're trying to get a certain number of points to possibly earn a grade in the class, there you go. This spreadsheet will kind of tell you what you need to get. Hopefully, there's no coding errors. I don't know if you look at my crazy Excel code that's up here. Good luck trying to make any sense of what I wrote. Um, it makes sense to me, but yep. So I wrote this not too long ago. But anyway. Let's go back to, I think that was our last problem, right? In for today. Yeah, that was our last one. So yeah, the answer is C, by the way. Maybe I'll circle up people who are watching but not listening. All right, everyone. Any questions before we stop? Nope. Nope. All right, then I'll stop the recording, guys. Thanks for coming, and I'll see you guys next Monday. Enjoy your Thanksgiving break, and make sure you get the next 5 questions done on the review to be ready for Monday.